Now suppose there is a reaction like 2 moles of NO plus O2 gives 2 moles of NO2, and the another reaction is NO2 plus CO gives NO plus CO2. Let's write the rate law for both. So here if I am writing rate law, then rate is equal to, I can say, K into molar concentration of NO whole square into O2. Well, in case of this, rate law is rate is equal to K into molar concentration of NO2 raised to 2 and into concentration of CO raised to 0. Means I can say rate is equal to K into NO2 whole square and CO raised to 0, anything raised to 0 is equal to 1. Now the question arises that now in this case I can say the coefficients, the powers are nothing but the coefficient, while here the powers are nothing but powers are other than coefficient, means the powers are not coefficient. Now question arises that why here the powers are not coefficient, why NO2 power is, the power of NO2 is 2 and power of CO is 0. So we have the answer for this also, that in which cases the power and coefficients are same, and which type of reaction, in which type of reaction the power and coefficients are not same. Why in the case of this rate of reaction depends on this and not on carbon monoxide. So just let's see the answers for all these questions. Now when I'm talking about such reactions, whether the power and coefficients are same or not, so we take a help of two types of reaction. We have two types of reaction. One is called as elementary reaction, the two types out of which, as I said, the one is called as elementary reaction, and the second one is called as complex reaction. Now what is elementary reaction and complex reaction? Let's see. Elementary reactions, these are the reactions which takes place only in single step. Means these are the single step reaction, I can say. The reaction get completed in a one step, while these are the reaction which takes place in more than one step. Two or more steps. The example for this elementary reaction, I can say here, the NO 2 moles of NO plus O2 gives 2 moles of NO2. The example for this, 2 moles of NO plus O2 gives 2 moles of NO2. This is called an elementary reaction. Elementary reaction which takes place in single step. Generally, if I will say, the majority of the reactions are single step only, but when we start writing its mechanism, then we come to know that reaction is not a single step, but it is taking place in more than one step. So mechanism, what we do in the mechanism, we split the reaction into the simpler part. So same thing here we are doing here also. The reaction is 2NO plus O2 gives 2NO2. When the question comes for writing the mechanism, when we write it's a mechanism, then also I will say, okay, the mechanism is also the single step only. Means the reaction at overall takes place in single step. It doesn't take place in two or more steps, right? So its a mechanism is also going to be same. Now, about the complex reaction, if I'm let us consider the example of complex reaction. The reaction is NO2 plus CO, which gives NO plus CO2. This is the complex reaction. NO2 plus CO gives NO plus CO2. Now, it also looks like a single step reaction. Only. But when we write its a mechanism, then we come to know that the reaction is not actually a single step, but it is a two-step reaction. So let us write its mechanism. Reaction takes place in two steps. The step number 1, NO2 plus NO2 gives one NO2 loses oxygen, other one gains oxygen, the same oxygen. So after losing it will become NO, and after gaining this will become NO3. And then step 2, the NO3 which is formed here, that NO3 is acting as an intermediate. You can see that here the NO is a part of this main product, means NO is a product, but NO3 is not present in the product of this main reaction. It means NO3 is acting as an intermediate. What is intermediate? Then simply I will say it is, these are the substances which is formed in one step and get consumed in the next step. Means in between the reactions only they form and they get consumed. So NO3, since being not a part of a product, main product, so it is going to be intermediate. So that intermediate combines with another reactant. In this I can say there is only reaction, in the reaction only one reactant has been taken part, that is NO2. Still CO is left. So NO3 combines with CO. NO3 combines with CO and produces, NO3 will give its oxygen to CO and we will get NO2 plus CO2. So you can see that we got to finally the another product also. So if I will add these two reactions, we will get the same. So let us add on addition NO2 will get cancelled. NO3 will get cancelled. So left is NO2 plus CO gives NO plus CO2. That's why we had written a single step reaction. But overall the reaction is taking place in 2 steps. So this reaction is known as a complex reaction. The complex reaction, that is a reaction which is taking place in 2 or more than 2 steps. Well, this is, if I'm going to write some mechanism, then mechanism also involves the same step. Matlab, actually the reaction is single step. Now in case of elementary reaction, it has been observed that the order and the power of the reaction, the power of the concentration term is nothing but the coefficient. Means if I'm writing it's a rate law, then here I will write rate is equal to, suppose if I'm writing it's a rate law, so rate law, that is the formula for rate, it will involve K into the concentration of reactant, that is NO and O2. So in case of elementary reaction, it has been observed that the power and the coefficients are same, and that's why here the power of NO is 2 and the O2 power is 1. So that's the reason that so since this example is an elementary reaction, that's why the power and coefficients are same. Now this is for elementary reaction. Now let's talk about the complex reaction. In case of complex reaction, this is the main reaction and these are their steps. The main reaction is a complex reaction, but when we talk about the steps, that is these 2 steps, these are considered as elementary reaction because they had, while writing a mechanism, we had already splitted them into the simpler form, means they cannot be splitted into still smaller form. So these 2 steps are elementary while the main reaction is complex. Now I want the main reaction, the rate of this main reaction. So to get the rate of main reaction, we will take the help of these 2. Now let us before this write the rate law for this reaction. So being elementary, its rate law is going to be, rate is equal to K into molar concentration of NO2. NO2 plus NO2 will be 2 NO2, means I can write raised to 2. Being elementary, the coefficient and power is going to be same. And if writing its rate law of this one, that is rate is equal to K into NO3 into the carbon monoxide concentration, that is NO3 raised to 1 and carbon monoxide raised to 1. The coefficients are 1, 1. Okay. Now we got the rate law that is the rate of reaction for the steps also. Now I want the rate law for this main reaction. Now since the reaction is taking place in 2 steps, so those steps will have the different speed. So here we come to know that this is a slow step, means the rate of this reaction is comparatively slower than this one, and this is the fast step. And the rate of a main reaction, it has been said that the rate of a main reaction always depends upon the rate of slowest step, or I can say the rate of slowest step and the rate of main reaction is always same. The speed with which the slowest step occurs, with the same speed the main reaction also occurs. It means the rate of this reaction, the rate of main reaction is going to be same. Now let's see why we are saying like this. Why we say the rate of main reaction depends upon the rate of slowest step. Then simple example I can say, suppose I am having a cycle manufacturing company. A cycle manufacturing company means the manufacture of cycle is nothing but the complex reaction, where we prepare the parts of a cycle and after that we assemble them. So that making of a cycle is a complex reaction like this, and making their part is nothing but the mechanism of that process, or I can say is the elementary process. So suppose the company have the different production rate for the different part. Suppose the first part, that is a seats, company produces approximately 500 per day. If I'm talking about wheel, the rate of production is approximately, suppose 2000 wheels per day. Then next is handle, that the production rate is 400 handle per day. And when I'm talking about the frame, that middle part, the production rate is approximately for this is 300 frame per day. So after getting all these are the elementary steps for the preparation of a for the manufacturing of a cycle. So this is the production rate for seat, this is for wheel, this is for handle, and this is for frame. So simply the question is, what will be the production rate for a cycle? That is, what will be the speed of the preparation or the rate of the preparation of cycle? How many cycle will be prepared in a one day? Answer will be 300. Why 300? Because the frame, without frame the cycle will not be completed. Why we are considering frame? Because this is the slowest step. So in this case also, the rate of production of cycle depends upon the rate of slowest step, the step which is taking place very slowly. Suppose instead of frame, if this was only 200 per day, if it was 200 per day, then rate of production will become equal to this. So rate of, in the same way I can say the rate of main reaction depends upon the rate of slowest step. So the rate of this slowest step is rate is equal to K into NO2 whole square. So the same rate will be for main reaction also, that is rate is going to be equal to K into NO2 whole square. And that's why we are having the same rate law for this particular reaction. The reaction is same. We can see that this is the rate law. Now in the case of this, I said the CO raised to 0. Why we consider the carbon monoxide is 0? Because the carbon monoxide doesn't take part in a slowest step. And since carbon monoxide is not present in a slowest step, that's why the rate of reaction does not depend upon the carbon monoxide. Okay, so this is about the elementary reaction and complex reaction. So in case of elementary reaction, I can say the power and coefficients are same, while in case of complex reaction, here the coefficient 1, 1, but the power is something different, that is order and coefficients are not same in case of complex reaction. Rate of this slowest step is also known as rate determining step, because the rate of reaction depends upon the same slowest step. So this is also known as rate determining step, that is RDS. So always keep in mind that if the reaction is a complex, then rate of the reaction depends upon the rate of slowest step, that is which is also known as rate determining step. Next is the molecularity of a reaction. After this two, molecularity of a reaction. Now what is the molecularity of a reaction? Okay, before this, suppose there is a reaction like A plus B gives product. Means there are the two reactants which are reacting together to form a product. Now we have a one theory called as a collision theory. Collision theory says that for a reaction to take place, the reactant molecules should collide together. The reactant molecules collide together and then only the product is formed. So if I'm using a collision theory here, then according to collision theory, a product will form only when the A molecule will collide with the B molecule. So when A and B collides, a product will form. If A and B will not collide, product will not form. So here, according to theory, these two should collide. So what is molecularity now? So molecularity is nothing but the number of reactant molecules which are colliding together. Number of reactant molecules collide together is called as molecularity of a reaction. So here in the case of this A and B, how many reactant molecules are colliding? 2. So 2 molecules are colliding. So here I can say the molecularity is 2. And if the molecularity is 2, then such reactions are known as bimolecular reaction. It is called bimolecular reaction. Here in addition to A and B, certain more collisions are also taking place, like A collide with A, B collide with B, but these collisions are West collision. They do not form any product. The product is formed only when A and B collide together. So here the molecularity is 2. Then second, Suppose I have another A plus B plus C, another reaction, which form product. So again, according to collision theory, a reaction will take place or a product will form only when A, B and C, all three collide together, that is simultaneously. If all three are colliding simultaneously, then only product will form. Then again I can say, so here ABC should collide together, then only the product will form. So in this case I can say molecularity is equal to 3. And if the molecularity is 3, then such reactions are called as tri-molecular reaction, which are having 3 molecules of reactant. In addition to this A plus B plus C, I can say this reaction is also known as tri-molecular reaction. 2A plus B gives product. Now here we have 2 different types of reactant, but the total number of reactants are 3, that is 2A plus B. So for a reaction to take place, 2 molecules of A and 1 molecule of B should collide together. If all 3 are colliding at the same time simultaneously, then only the product will form, otherwise product will not form. Then third, suppose the third one, A plus B plus C plus D, the 4 reactants are there and they are forming a product. So according to collision theory, a product will form only when A, B, C and D, all 4 are colliding together. A, B, C and D, if all 4 are colliding together, then only product will form. So they should collide together at the same time. Now the possibility or the chances for colliding all 4 molecules together will be very, very small. Means the very less number of time means it will happen very rarely it will happen that all 4 molecules should collide together. It means the product formation speed is going to be very less because the chances for colliding all 4 is very less. So here the rate of reaction will be very, very slow. So such reactions are carried out by using some other method if the molecularity is greater than 3. Because if the molecularity is greater than 3, then rate of reaction is very slow. The reaction is slow because, as I said, the tendency or the chances for colliding all 4 molecules simultaneously is very, very less chance. Okay. Now after this, suppose I have a reaction like 2A is giving product. 2A is giving a product, it means the 2 molecules of A should collide together, then only product will be formed. That is 2 molecules of A means A and A. So such reaction, again I can say molecularity is 2, that is the reaction will be called as bimolecular reaction. Suppose another example where I can say only single molecule A is giving product. A is giving product means there is only one molecule, so it will be a unimolecular reaction, that is the molecularity is 1. So such reactions are decomposition. So only single molecule is forming a product. So such reactions are example of unimolecular reaction. Now we have some more reactions like elementary. Now tell me what will be the molecularity in this reaction. So here molecularity I can say 2 moles of this plus 1 moles of this. That is molecularity is going to be 3. 3 molecules are reacting. Here if I will write the order of reaction, the order is going to be 2 plus 1, that is 3. And if I am writing the molecularity of this particular reaction, then molecularity is also going to be 3. That is 2 moles of this and 1 moles of this. 3. To know the order of reaction, we have to perform experiment, the order of reaction which is a sum of powers. So to know the order of reaction, it is very necessary to perform the experiment to get the values of x and y, and then you can write order of reaction. But to get the molecularity of reaction, in all the cases we predict the molecularity of a reaction directly without performing any reaction. Means the molecularity of reaction can be predicted or can be written only from the balanced chemical equation. If you want the molecularity, then for molecularity we just add stoichiometric coefficients. That is, molecularity is, I can say, theoretical concept, while order of reaction is considered as a experimental quantity. So here for this particular reaction, the molecularity is 3. Now let's talk about the molecularity of this reaction. Molecularity of this reaction, if I am thinking that molecularity is going to be 2 because 2 reactant molecules are there, then I will say molecularity will not be 2. The reason, because according to the definition, the molecularity is the number of reactant which are colliding together. Here we are having NO2 and CO, but when we observe the mechanism, we can simply say that there is no interaction between the NO2 and CO, and hence the molecularity cannot be 2. Here There are total 4 components. Again, I cannot say that molecularity is a 4 because all 4 reactant molecules are not colloiding together or simultaneously. Molecularity means the number of molecules should colloid together or simultaneously. So in this way, I can say that molecularity of this complex reaction cannot be written, because while writing in the case of complex reaction, we cannot decide the number of reactant molecules which are colloiding together to form ultimate product. So always keep in mind, molecularity concept is only applicable for elementary reaction. It doesn't have any significance for complex reaction, means it is not used for complex reaction. Yeah, but I can say for the steps, these steps are elementary. Steps are elementary. We can write the molecularity for each steps. Here the molecularity is 2. Here the molecularity is, here again the molecularity is 2. But for complex reaction, we cannot write the molecularity. Sometimes we say that the molecularity of a complex reaction is equal to the molecularity of the rate determining step, that is the rate of slowest step. But again, I will say this statement also have no significance. So in short, the molecularity concept is not applicable when the reaction is a complex. It is applicable only when it is an elementary reaction. The definition itself, the molecularity definition itself says that the molecularity of a reaction is defined as the number of reactant molecules colloid in an elementary reaction. That is a definition. The definition itself involves the elementary word. So this is about the molecularity of a reaction. Okay, now let's see the some differences between the order of reaction and molecularity of a reaction. Order, and the second is molecularity of a reaction. Order of reaction, molecularity of a reaction. Now what it is? They are the different terms, but they are the different terms. Order of reaction, I can say this is this we obtain by, this is the sum of the power, means by adding sum of the power in a rate law. While the molecularity of a reaction, I can say it's nothing but the sum of coefficients reactant coefficient in a balance equation. Order of reaction is a sum of power, that is a sum of x and y. So I can say order of reaction, to get the x and y, we have to perform an experiment. So I can say it is an experimental concept, or it is an experimental quantity. While to get the molecularity of a reaction, we have to just balance the reaction, and from the reaction we just add the coefficients. So balancing and the addition of coefficient doesn't involve the experiment. So it's a theoretical concept, that is to get the molecularity of a reaction, no experiment is performed. Since it is an experimental concept, that's why I can say that order of a reaction depends upon experimental condition. While the molecularity, since it's not an experimental concept, so it doesn't depend on the experimental condition. Then order of reaction can be 0. We have 0 order reaction, while molecularity can't be 0. Molecularity cannot be 0, because if I'm saying molecularity is a 0, it means there is a no reactant. The number of reactant molecule is 0, and such reaction is not possible where there is a no reactant. Then molecular order of reaction can be fractional again. But molecularity, it can't be fractional. Again, molecularity is nothing but the sum of the coefficients, and while balancing, we never use a fractional number. Means if there is a reaction like A plus B is giving some product, while balancing we always use whole number. We never use like half or 2 by 3. And if I'm not using any fractional number, then the sum will not be a fractional. So it is always a whole number. natural number I can say, because again the 0 is not considered. Then order of reaction. It is applicable for both elementary as well as complex reaction. It is applicable for both. While molecularity, it can be calculated only for elementary reaction. This concept is not applicable for complex reaction. So this is applicable for both elementary and complex, while this is applicable only for elementary reaction. So these are some differences between the order of reaction and molecularity of a reaction.